Welcome to this lesson on creating graphs and charts. Being able to represent data visually is a key numeracy skill, and you'll see plenty of graph-related questions on the LANTITE. Today, we'll cover column graphs, line graphs, pie charts, stem and leaf plots, and dot plots. We'll also learn how to choose the right graph for the right data. By the end of this lesson, you'll be able to create the 5 most common graph types. Choose the right one for a given dataset and label everything correctly. Proper labeling is essential on the LANTITE. You might be asked what's missing from a graph or what makes it misleading. Let's start with the basics of good graph construction. Before we create any graphs, let's talk about what every graph needs. First, a title that tells the reader what the graph is about. Second, labeled axes with units. The horizontal axis and the vertical axis must both be labeled. Third, an appropriate scale with even spacing, usually starting from 0. And fourth, a key or legend if you're showing more than one dataset. On the LANTITE, you'll often be asked what's missing from a graph or why it's misleading. Missing labels and scales that don't start at 0 are the most common answers. Let's create our first column graph. A Year 3 class voted on their favorite fruit. Step 1. Draw 2 axes. The horizontal axis shows the fruit names, and the vertical axis shows the number of students. Step 2. Choose a scale. The maximum value is 8, so we'll go from 0 to 10 to give some headroom. Step 3. Draw equal width bars with gaps between them. Step 4. Add a title. Label both axes and put scale markings on the vertical axes. Notice the bars are the same width, evenly spaced, and the scale starts at 0. Now let's create a line graph. A teacher recorded the temperature at noon each day for a school week. Line graphs are ideal for showing how data changes over time. Time is on the horizontal axis and temperature on the vertical axis. We plot each point and connect them with straight lines. Notice the temperature rises to Tuesday, drops on Wednesday, falls sharply on Thursday, then starts to recover on Friday. Line graphs make trends like these easy to spot. Now let's create a pie chart. A survey of 40 teachers found their preferred teaching area. Step 1. Calculate each category as a percentage. English is 12 out of 40, which is 30%. Maths is 8 out of 40, which is 20%, and so on for each category. Step 2. Convert percentages to degrees by multiplying by 3.6. So English is 30 times 3.6, which is 108 degrees. Step 3. Always check that your angles add up to 360 degrees. 108 plus 72 plus 54 plus 90 plus 36 equals 360. Perfect. A stem and leaf plot is a clever way to organize data while keeping the actual values visible. The stem is usually the tens digit, and the leaf is the ones digit. So, for 63, the stem is 6 and the leaf is 3. The data here shows test scores for 15 students. We arrange them so each stem is listed once on the left and all the leaves for that stem go on the right in ascending order. You must always include a key, like 6 bars 3 means 63. This type of display is common on the LANTITE. The dot plot is one of the simplest graphs. Each dot represents one data value stacked above a number line. Here we have the number of pets owned by 20 students. 0 pets has 4 dots, 1 pet has 8 dots, 2 has 5 dots, 3 has 2 dots, and 4 has 1 dot. Dot plots work best with small, discrete data sets. They make it easy to see the most common value and the spread of the data at a glance. Choosing the right graph is a very common LANTITE question. Here's a simple guide. For categorical data, like favorite colors or transport methods, use a column graph or pie chart. For data that changes over time, like temperature or sales figures, use a line graph to show trends. For small discrete datasets, a dot plot works well. For numerical data where you want to see the distribution, a stem and leaf plot keeps all the actual values visible. And for showing parts of a whole, a pie chart is ideal. Remember this guide for the LANTITE. You'll often be asked which graph best suits a given dataset. Cumulative frequency is the running total of frequencies. You add each frequency to all the ones before it. For 0 to 9 minutes, the frequency is 3, so the cumulative frequency is 3. For 10 to 19 minutes, the frequency is 7, and 3 plus 7 gives a cumulative frequency of 10. We keep going. 10 plus 8 is 18, then 18 plus 5 is 23, and 23 plus 2 is 25. The final cumulative frequency should always equal your total number of data values in this case, 25. This is a good way to check your work. Let's cover the most common mistakes. First, forgetting the title or axis labels. Every graph needs these. Second, using an uneven scale on an axis, like jumping from 2 to 5 to 10, this makes the graph misleading. Third, using the wrong graph type, a line graph, for categorical data like favorite colors doesn't make sense because there's no logical order to connect. Fourth, pie chart angles or percentages that don't add up to 360 degrees or 100%. And fifth, stem and leaf plots with leaves out of order. They must be in ascending order from left to right. Now it's your turn. Pause the video and try these 6 problems. Problem 1. Which graph type is best for showing how temperature changes over a week? Problem 2. In a pie chart, what must all the sector angles add up to? Problem 3. Given the stem 7 and leaves 2, 5, 8. What are the 3 data values? Problem 4. Create a frequency table from the given data set. Problem 5. What essential element is missing if a graph has bars but no vertical axis label? And problem 6. In a dot plot showing pet numbers, if there are 5 dots above the number 2, what does this tell you? Check your answers on screen. Let's recap. Column graphs compare categories. Line graphs show change over time. Pie charts show parts of a whole. Stem and leaf plots keep actual data values visible. And dot plots are great for small data sets. Every graph needs a title, labeled axes, a consistent scale, and a key if there are multiple data sets. On the LANTITE, remember to match the data type to the correct graph type, and always check for missing elements when you're asked about misleading graphs.